All right, folks, welcome to Privacy Pass at IETF 115. I'm here in London, and Ben is online. And thank you all for coming. Um, let's see, just a few things. I know this is the bitter end of the meeting, and so the note well, you've all seen this before about what you should consider before you're contributing to the IETF and code of conduct. So I'm just going to leave that up there for a brief second, but if you're not familiar with it, obviously you should be by this time in this week. Code of conduct, this group is in general really good, but we want to make sure we treat everybody with respect and keep focused on engineering solutions. All right, here comes the hardest part of the meeting. We are requesting a note taker. Don't all jump up at once. Folks online can do it too. All right, thank you, Florence. Next, let's see. So when you're in the meeting room, please sign into the on-site meeting tool so that you can join the queue. It makes it a little easier to manage the queues between remote participants and local participants. You know this already. You've been here a while. All right. For our agenda, we have a couple of discussions of working group drafts. Right now, we have our core documents either through working class call or in working group last call. And we really, for the ones that are in for the issuance document and the HTTP auth scheme, really want to make sure we get good review of that. I haven't seen much activity in GitHub lately or on the list. We want to make sure these documents are ready to move forward. So please put your reviews in. Tommy?
Yeah, just to comment on that for the core docs. We did get some good review on the auth scheme, and we sent that over to HTTP, and we made some adjustments based on that. So
okay,
thanks for
I may
that.
have missed that.
Yeah, but I think definitely emphasizing the call for review on the issuance protocol, since that one has not received.
And it would also be good. I mean, these documents have been around for a little while, so you know, even if you've read them and you feel like they're ready to move forward, letting us know on the list would be helpful, because there may not be much to comment on at this point, but we'd like to make sure that these are being reviewed. We did have a plan for some time to talk about key consistency, because that's a newly adopted draft, but we did not have anybody take us up on that. So we're going to strike that from the agenda today. But if anybody wants to make any comments on that, that would be fine. Other than that, we have a few other presentations. Is there any other business that anybody thinks we need to conduct at this time or modifications to the agenda? All right, given that, I think, Tommy, you're up. And I'll assume that you'll take control of the, let me just get rid of this. And you should be able to share the slides, right?
Yeah, if you just grant request, yeah, perfect. Thank you. All right. Hello, everyone. I'll be giving the update on the rate limited issuance document, which was adopted since last time. And one of our co-authors, Stephen, is in the room. He'll be presenting some stuff later, but he can also help chime in. So the two things we wanted to go through today was, one is just a recap of the differences in rate limited token issuance as compared to the basic token issuance, just to remind people, since this is the first time we're presenting this as a working group document, and so take a look and make sure you understand and are happy with the current shape that's in. And then we'll go through some of the open issues. There's essentially one major open issue, and then we'll just mention some of the other smaller ones. All right, so starting with recap, what are we doing here? So this is an extension essentially to the basic issuance protocol. It is based on the publicly verifiable variant, which in the basic one is type 2. And the difference here is that this is essentially always done in the split attester and issuer model, whereas with the basic type, you can either have them split or combined. And in this model, the attester is maintaining some state on behalf of the client, essentially counting the number of tokens that a client has received for an anonymized origin bucket. And this is a bucket that is defined by the client. It provides an anonymized origin ID, and the attester can use information it gets from the issuer to validate that this anonymized origin ID is indeed a one-to-one correspondence with some origin, but it doesn't know which. Upon requesting a token through the attester, that goes to the issuer, and then the issuer in its responses to the attester adds an extra bit of information, which is a rate limit to enforce. And so it gives out a token and then says, this is the number of tokens that I'm going to allow for this origin. And the issuer does not learn if that rate limit was reached or not, but the attester uses that to drop the request if the limit is reached. So looking at this visually, again, there are two halves of all of the different privacy pass protocols. There is the side that actually talks to the origin, that's the challenge and redemption flow, and then there's the side that is the issuance flow. So there's a very minor change to the challenge and redemption flow. Well, there's actually no change to the redemption, and the challenge only has to include one new key, and this is a HPKE key that corresponds to the issuer, so that the client knows how to encapsulate the actual origin info and the origin name when requesting a token to the issuer. And then on the issuance protocol side, the main differences are what we alluded to before, but more concretely here, there is an HPKE encrypted inner request to the issuer that the attester passes along, but it cannot read, that contains the origin name. There is an anonymous origin ID that the client communicates to the attester to be this bucket for keeping counts. There is the token rate limit per time window that the issuer communicates to the attester. And then there's also a set of signatures that the client provides and that the issuer also provides input on to prevent the client from cheating and saying that what is in reality one origin, trying to make that look like it's two. Looking on the chat, the origin here chooses the singular issuer and gives, yeah, so any particular challenge is related to one issuer. The origin can provide multiple challenges, but any particular request for a token is bound to an issuer. And that's the same as the basic types. That's no different from that. So looking at the actual on the wire bits. So this is how the basic token request looks like for the publicly verifiable type. It has the token type, key ID, and the blinded message. And the difference for the rate limited, it has a different token type, and then it has the stuff in green, which is a HPKey protected inner request that gets passed along, and then it also includes information for the signature. And then the inner request is what includes the key ID, the blinded message, and the origin name info. All right, so that is the recap of the protocol and its delta from the basic type. And so going into the issues, the main issue that we've been discussing recently is number 6 on the GitHub, which is about a linkability attack that was not detected earlier on that has to do with a malicious issuer. So in this case, the malicious issuer is reusing something called the issuer origin secret across different origins. This is the secret that is used in the responses from the issuer to the attester that help the attester verify that the client is not cheating in terms of what it's claiming as its anonymous origin ID. So the point is that the issuer can essentially confirm when it's working well that what the client claims are 2 different origins really are 2 different origins. However, the issuer could maliciously say that, oh yeah, all of my origins are the same origin, to essentially make it look like the clients are cheating or malicious. And based on the current text in the document, when the attester detects this collision, since it was assuming that that is a malicious client, it currently just says you drop that request on the floor. And that is kind of the root of this particular problem, because if you are dropping that on the floor, then that is potentially a signal kind of going out to whoever requested the token that maybe the reason that this request didn't get a successful token back was because you had hit this collision, which implies that you had previously requested a token for a different origin, right? So if you had various origins colluding with their issuer to say, hey, make me collide with this other origin, and then I'll try to guess that when a token fails to be generated, it was because that client had previously talked to a different origin. It's not a particularly direct signal. There are many reasons that the token issuance could fail. You could have hit your rate limit. The attester could have not liked you for some other reason, but it is kind of a bit of information that you could leak if the attester naively just drops requests. So the proposed fix that we think is the kind of the smallest delta and kind of the correct thing to do for the protocol is to not just naively, silently drop a request if you see this type of collision. Not only does that allow a malicious issuer to leak a signal, but it also isn't particularly useful. Let's say we do have a malicious client that is intentionally trying to make different or make one origin look like multiple different origins. Silently dropping the requests on which they're trying to cheat and not doing anything else is probably not the right thing to do. The whole point of this attester vouching for the client is that it is attesting that it meets some bar, that it is a legitimate client. And if the attester has detected cheating, it should probably instead, penalize the client, or say, you're no longer someone I'm willing to serve tokens for. So overall, we need to work on the text here, but the proposal is that instead of just dropping a request silently, the attester would flag the collision events and use the collision patterns to reevaluate trust in the issuers or clients. And in general, with non-malicious implementations, these cases should, you should never have these collisions. So if you have them, they do indicate that someone is messing with you. If you have a case of a malicious issuer that is using the same secret across multiple origins, the pattern that should become visible is that you're going to start hitting collisions across many different clients. If the attester detects this situation, it should, rather than just dropping a request, it should essentially, remove the issuer as a trusted partner, or kind of, put them in a penalty box at the very least. And similarly, if it's a singular client that is doing this, and it's not across many different clients for a particular issuer, then the heuristic can say, we're not going to issue any more tokens in the future to that client. So overall, rather than dropping a particular request in the moment, the approach should be rejecting future requests for that client, or if you detect eventually that this is more likely the issuer problem than is the client, then you stop using that issuer, which effectively stops letting any client talk to that issuer through that attester. As a bit of sidebar, we filed another issue that we should have more text in this entire area. As we were talking about it, we've for the basic types, we already have some experience with attester and issuer deployment. We're getting a lot of more issuers being deployed for the basic types, and we're working with our attester. And there is already a fair amount of validation that needs to go on between an attester and an issuer. There are things beyond just its pattern of, are you being malicious or not, but are the lengths of the windows that you have for enforcing a rate limit an acceptable thing? You shouldn't have windows that are 1 minute long. You shouldn't have a window that's a year long. So there are things that the attester needs to validate before it's willing to trust an issuer. For that, the different rate limits, there may be bounds on that. You may not want to accept a rate limit of 1. You may not want to accept a rate limit of 1 million. And so there are values that you need to be able to validate there. And of course, you also need to make sure that if this is kind of a generic case, that the issuer you're working with has enough different origins being served to create an anonymity set. So I think overall, there should be more text in a section on the trust relationship between the attester and the issuer. And part of that then would be the collision detection. Then the other direction I do want to bring up for that malicious issuer attack, there was an alternative approach that Nikita brought up and we discussed, and I know he's on the call here, which would involve a completely different approach to the signature that currently prevents the clients from cheating, that instead of using that CFRG work, you would instead use a zero knowledge proof that the client would present to both the attester and the issuer, and it'd be kind of like a one-way thing. So this is cool. It does, however, rely on new crypto that's not specified yet in any document, and would have more impact on the protocol and who knows what, and how you would have to deal with other normalization issues. So, this is something that, were we to go in this direction, would need a lot more, starting from scratch in CFRG, other discussion, and we're not sure all the details of how it would work. So, I think my recommendation and our recommendation as the authors is to, for the basic rate limited type that we're defining now, do the fixes that we previously mentioned, but have the zero knowledge proof direction be a candidate for future token types and future work in this area. Once it's gone through CFRG, other groups and other analysis. I think there's other features that people have discussed beyond just like a basic count of rate limit that could involve state or these more complex relationships, and bundling the new zero knowledge proofs, if that would make sense to me. So yeah, I see some comments in the chat that, yeah, it does seem like a big change. But yeah, I think it's very cool, and I think we should keep pursuing it. I think one of the benefits of the architecture that we are using is that we have flexibility on token types. We can define new token types that people can move to, that can bring us new cryptographic algorithms, that can bring us new capabilities and properties. So I'd like to see this used there.
And we do have somebody in the queue if you'd like to take
Oh,
a
do we?
question. Yeah.
Oh, sorry, I didn't see it. John.
Not a question, just the note that the Jose work group is in the process of being rechartered by the IESG to formalize JWP, which is pretty much exactly what you were just talking about. So there is the Jose working group is intended to look and formalize how to do JSON tokens with zero knowledge proofs based
Cool.
on approved algorithms from the CFRG. So that is in process. If people are interested, then pay attention to the newly reformed Jose working group should the CFRG approve it next meeting.
Got it. Yeah. We will definitely want to track that, and yeah, I'll also see what common bits are present in CFRG then. Thank you. Great. And so then the other open issues, there's some discussion about the token key ID length and if that should change. There's a discussion around ways to potentially hide the issuer rate limit from the attester. That is something that we think may work better in a future token type, kind of like the zero knowledge proof. There is an issue, let me try to just remember this. Yes. I think we need more discussion and text around how you deal with rate limited tokens when you have an origin info that lists multiple origins. So this is like when you have a third party, let's say you have like a reCAPTCHA embedded on some other website, and it wants to do a rate limit, and how you handle which one is kind of the one you're limiting on. And then this last one I mentioned, where we want to expand the text on the trust relationship between attesters and issuer and what they need to validate against each other. So that's the end of the slides I have here. I think our main next step is to update the document for these issues based on what we discussed here. If people have opinions, we'd love to hear that. We are still tracking the CFRG dependency for the signature key blinding. That helps us do the proof that the clients are not cheating. And other than that, we're gonna keep working on this. Any questions?
There were a couple questions in the chat. I don't know if folks are wanting to bring those to the mic.
Yeah, I tried to address some of them as I saw them coming by, but Nick.
Yeah, thanks for the overview. I was asking about the I think it's an encapsulation key, right? The origin provides. I want you to go get a token from this issuer and gives you a particular key to use to encapsulate your request. And that just seems like a potential tracking vector. I know there are other tracking vectors if they collude, but that seemed like a potentially significant one. And it seems like there's some mitigations in the document about a tester can help mitigate by trying to make sure that the key isn't unique or something. Is the assumption that, okay, there should be a single key for each origin? Like there should be a universal, a consistent key for each origin. Is that right?
Right. And so part of this overlaps with the key consistency document and approach. But yes, there is, for the HPKE key, there would be one, or one slowly rotating key for that issuer. And so you need to make sure that you have the same key as everyone else, and the working with the attester is one way to do that. That, like, if you're doing a kind of key consistency approach, you have one source, which is the origin, telling you here's the key to use, and the attester can also potentially be a vector to validate that. That is the same as what it sees across all other clients.
And does that, I mean, if it is going to be that sort of consistent, does it even need to come from the origin, or just should there
No,
be a key known for an issuer and the origin's not involved at all?
Yeah, it definitely doesn't need to be. And I don't recall offhand, but I think it is optional, like, because even in the basic token requests, the origins include, for example, like the RSA blind signature public key that they're going to verify against. That is something that doesn't strictly need to be in the challenge if the client has another way to get it. So origins could leave it off, and then essentially force the clients to fetch it some other way, but it is defined as a parameter that can be included in the challenge, if that makes sense.
Yeah, that's helpful. I mean, it does seem like we should have as little information coming from the origin that could be used to directly communicate with the issuer.
Yep. That's a good point.
Thanks.
Yeah, I think sometime when we have more key consistency discussion, we should talk about how those relate. Ben, you had a question on the chat about the blinding being symmetric encryption. Was that answered? Do you want, or
I'm very naive about all this stuff. I've been trying to figure out if the key blinding is just equivalent to taking the public key and encrypting it under symmetric encryption and passing the password around. about passing the symmetric key around as needed. Is that all that the key blinding is actually doing here?
I don't know if Stephen or others would want to comment on that.
Stephen, Google. So the scheme there is slightly more complicated than just the symmetric thing. Like it's using the public key of the issuer, but then we have the extra binding so that the attester can verify some anonymous ID that the issuer provides without like learning the actual origin or key information. So it's like slightly more complicated. If we didn't care about the attester and not learning like the intermediate result, you could use something more symmetric. But I think that's why we need the like key blinding, like the RSA key blinding dependency here.
So I'm not talking about RSA blind signatures. I'm talking
Yeah,
about
we're talking about the key blinding. Yeah.
okay.
I-
Yeah,
so
I'm happy to take this offline. I don't need to waste time on this.
yeah, I would rather that Chris Wood and some of the other authors on that comment authoritatively. I don't want to perjure myself. All right. Okay.
Any other questions? All right, so it sounds like we have kind of a way forward for some of the issues raised. Some of the other ones still maybe need a little bit of work, but seem relatively straightforward. So
Yeah.
I guess we'll expect some revisions and work on this document over the next couple months.
That's right. Thank you.
Awesome. Thank you. All right, I believe next is it, I think we have Stephen up to talk about what's going on in W3C. Let me get your slides up. I think I've never tried it. Can you share a slide through that? Maybe you need to do the sharing then. Or do I share or do you share? I think it should show as a request to me. Okay, you should have it. Cool.
Cool. So I'm Stephen from Google. I'm going to give a quick overview of the current state of privacy pass-esque work in the W3C and where some of the next steps might be there. So there's a few relevant work, some of them in the W3C and some of them not quite there yet. There's private access tokens by Apple, Cloudflare, and Fastly. There's private state tokens, which was for a while known as trust tokens. There's a device attestation use case that has been coming up in the W3C, and there's a few other uses that have come up, so I'll go over them and we'll see how much of this is purely W3C work or how much of this might be work that we want to pursue in the future in the Privacy Pass group. So first, private access tokens is one of the more mature things. It's based on currently the blind RSA and the rate limited tokens draft that is currently undergoing adoption that Tommy just talked about. It's pretty close to the existing Privacy Pass protocol. There's very minimal deltas. The things that you need to do in the W3C to support this are there's a fetch API. This is different from like the JavaScript fetch API, but this describes how web requests and web responses attach various information, such as the WW authorization headers that we see in Privacy Pass in the authorization draft. There's also some question if there's a way to delegate usage of this API, and that's also going to require W3C work to allow this API to be used outside of just the top level. So for this particular API, I think it currently doesn't exist in any community group in the W3C, but I think it would likely end up in either the WCG, which is the web incubation group, or the anti-fraud CG, which is a group working on a bunch of anti-fraud technology, which private access tokens sort of falls under. As a quick aside, the W3C has a bunch of different groups. There's interest groups, which are exchange of ideas, community groups, business groups, working groups. The important distinction here is that community groups tend to do like early work on various ideas, but don't actually produce deliverables or standardized documentation. Eventually, once something is in a good enough state there, it'll move into some working group. I think for Privacy Pass related technology, this would likely be Web AppSec, though if there's a lot of interest and a lot of like things derived from Privacy Pass, it might be worth having a new working group. So I think the general structure is we'll have community groups working on this sort of things for early design and getting input from other folks, and then move it to a working group to actually create a deliverable of effectively an RFC finalized document. So to talk a little bit about how private access tokens usage format works, right now token issuance is a trusted attester. In the Apple case, it's the Apple platform, and I think that's the general idea for access tokens. And then any website is allowed to redeem these tokens to have some proof that like you can access this resource because you have a real device or a legitimate platform. And then to do rate limiting with the rate limiting draft dude, both rate limit of each origin is only allowed a fixed number of tokens, so you don't like go take 100,000 tokens from one device and go spread them to a bunch of malicious devices. And there's also rate limiting based on the attester can rate limit, like you don't want to be spitting out a ton of tokens for one specific device, just since these sorts of token farming attacks are quite common, at least in the web space around cookies, and we'd expect similar things with private access tokens and other Privacy Pass related technology. So another API undergoing work in the W3C is private state tokens. It was formerly known as trust tokens, but both the name trust there didn't quite reflect what it actually did, and it was better to try getting it to a closer, more coherent story with all the other tokens that are undergoing work. It is based on a very old version of Privacy Pass, the VOPRF draft, and I think from like 3 years ago, and a not standardized PMB tokens draft, which is a version of Privacy Pass that has private metadata. I think there is a plan to update this to the more recent version once the drafts are finalized and we have an RFC cut of it. And hopefully a PMB tokens draft that's still of interest in the IETF could get standardized, though it's unclear how much interest there will be here and how useful that is. It is currently in the WIC-G. We're hoping to move it to the anti-fraud community group just because while the web platform incubation group, like there's lots of documents in that, you don't get as much feedback and response there. And anti-fraud, I think, is the core use case of that API, so we hope to move it there. Let's see. The model there, unlike private access tokens, is that any website, either first party or third party, would be issuing tokens if they have some concept of the user's like legitimacy. I think the reCAPTCHA, HCAPTCHA case is the primary one here. Also, if you have a strong first party identity, and then you're willing to share that information, that might be another case where you want to be issuing tokens. And then other origins can redeem tokens from those particular users. There's likely going to need to be some sort of partnership between the issuers and the folks redeeming, just because they need to know what a token means. Like if you get a token from some random issuer and you don't know like what it actually is attesting to, what it's actually promising, that's less useful, at least for these sorts of ecosystems. One other thing in private state tokens that's slightly different from Privacy Pass is to avoid having to spend a token for all like 50 requests you might make on one top level page. There's a concept of a redemption record, which is basically like a stored local cached version of the redemption. Though this is sharded by the top level to like avoid that redemption record acting as a cross-site tracking vector. Let's see. So some other deltas from the Privacy Pass protocol that hopefully will go away as various things get standardized or we update to the new RFCs is for private state tokens, in order to get key commitments and to avoid the like different users getting presented different keys, we're using the database discovery model, which is described in Chris's draft, which is basically there's a central service that fetches all the key commitments and those are provided to clients. Having some sort of standard around like how this actually functions beyond the random thing that's written for private state tokens would be good. And hopefully some of that work can come out of the key consistency draft. Currently, private state tokens, instead of using the application private token request method where like use an entire post, it instead runs the Privacy Pass protocol via headers on existing fetch requests or existing XHR requests. I think this was partially an optimization because having a completely separate request was an extra overhead. That's possible we can just move to this post method, and with a lot of the H2 things allowing for pooling of connections and requests, the value here might not be all that useful. Another thing, though this is unlikely to be specified in the IETF, is that there's a way of triggering all this using the fetch JavaScript API instead of just HTTP authentication. The idea here is that there are various websites that won't want to do a full, like, run a separate request or have to embed a separate, like, iframe on the page in order to get tokens, or if you want to do it in the middle of other activity happening on the page. I think we hope to also add HTTP authentication to the private state token, so it would be a strictly like superset of what's currently provided in Privacy Pass and what private access token does. And as I mentioned before, there's the redemption records, which help solve some of the latency issues where you have a bunch of requests from the same top level origin. Okay, so moving on to slightly less fleshed out solutions. A common thing that's come up in the W3C anti-fraud group has been the idea of having some sort of device attestation, similar to private access tokens, but like some way to attest to facts about the device or attest to facts about the client. But this needs some sort of mechanism, some sort of anonymous credential style mechanism to do this without leaking information about like this particular device ID. Some variants of Privacy Pass might be useful here, either building up on the private access tokens, private state tokens, or some other variant if there are other types or other parts of that attestation work that either need slightly different features or don't need a lot of the extra complexity here. Let's see. There also have been a few other uses, also similarly less well thought out. In PATCG, which is the Private Advertising Technology Community Group, there's a thing called the Aggregate Reporting API. This is basically clients send reports, but there needs to be some way to authenticate this, avoid attacks from fake devices or devices that aren't authenticated in some way. You don't need a like real user identifier attached to this reports. You just need someone somewhere like was fine with this. And attaching something like Privacy Pass might be useful there. There are a few complications here where you want to bind tokens to like particular origins or include some amount of public metadata inside beyond just the like your choice of keys. So we need some of the more complicated public metadata forms of Privacy Pass for that case. But yeah, PrivacyG has been visiting other sorts of privacy preserving technology, so there might be some work there. And then at TPAC, the WebAuthn and Web Payments folks had a joint session with the anti-fraud group, and there was some vague interest in various blind signature methods, anonymous credential methods there to test to something about like, you've worked with some instrument provider, some credit card provider, some bank, and you want to attest to some facts about that, and Privacy Pass or other variants of this might be useful in that space. I think that's all.
Okay, I think Martin's in the queue if you're ready for a question.
Yeah, Martin Thompson, I just want to avoid creating a mistaken impression about some of these things. I think this might be misrepresenting a little bit what PATCG is actively working on. There are proposals in that community group to adopt, I think, the aggregate reporting API is just one of the candidates that's being discussed. There are some designs that don't require to the same extent those sorts of capabilities as a result of their design. So there are some designs that rely very heavily on something like Privacy Pass, and others that rely on it somewhat less so.
Yep, to be clear, with the device attestation and the ones here, this is places where Privacy Pass-like technology has come up. It's not necessarily a hard requirement or even likely to happen for these, but it's places where we might want to look at for future use cases or other extensions that might be useful in the space.
Okay. Cool. So it sounds like there are some dependencies between the two groups, but right now is there any problems that we need to address, like with respect to expectations of the W3C on work that we're doing or vice versa?
So yeah, I think for a lot of these, it's still in the early stages, so there's no strong expectations. I think depending on how the standardization process and the input we get in like the various CGs, like some of these things, particularly the key consistency, might be useful to have some baseline sorts of things in the IETF. I think for most of these, we already either have that through the rate limiting draft or some of the other items undergoing adoption, but maybe good future points to future work once that like gets to that state.
Okay. Ben?
Hey, So it sounds like the work in the W3C is really pretty nascent. There's none of these proposals have actually moved into a working group. So what are the odds that by the time any of this work actually is moved into a working group, it'll turn out that the specifications that we've written now actually are not what's needed, and that it turns out that, for example, what the working group wants is PMB tokens or some other arrangement with properties a little bit different from what we're specifying.
I think that's one of the benefits, at least of the way the core protocol models are structured. Like, if we need slightly different properties, we can come up with new token types and work on standardizing those. At least I think the general issuance redemption format of the core protocols is pretty in line with what we've seen, and I think it's mostly just going to be a question of additional token types to expose whatever features we need in the space.
Okay, thank you.
Tommy?
Yeah, just to answer a little bit also to Ben's question there. I think the benefit of how we ended up designing the HTTP auth scheme in Privacy Pass means that it is usable kind of by various websites without a W3C particular adoption or change to JavaScript APIs. So people are able to deploy it and use it independently. And so like our W3C is not our only customer directly, right? Like people can benefit from it independently. I think there's also some very minimal work that can be done to, like we're talking about, can you mark on like an iframe specifically which iframes or third parties are allowed to issue token challenges or not, and what the browsers will accept. And that's something that you could do very surgically and minimally within W3C work that would integrate well with what we're defining here in Privacy Pass. And then there are these other use cases which may be able to use Privacy Pass as we're defining it, or may need a new token type, but I don't think it's invalidating the basic types. I think the basic types are still a good foundation that will be used regardless of how complex the adoption in W3C is on top of them.
Okay. Any other comments or questions? Nick?
Yeah, is there documentation or a specific proposal on the private access tokens? I personally wasn't aware that was using a rate limiting version of this, and I'm sure that's my fault, but just if there's somewhere I could be reading that, or if that is likely to go through standardization at W3C, then that would be helpful. Thanks.
Tommy, maybe.
Yeah, I can respond to that. So the private access token name is just it's not a formal thing really. It's what, when like Apple talked about our tester, that's what we talked about at our conference because that's what marketing wanted to call it. Really all that is just the basic publicly verifiable Privacy Pass token, and saying that we support it, and we also intend to support the Type 3, and other testers and platforms can support those as well. So I think the parts on top that this is referring to is, do we have changes to fetch or permissions policy that really probably they wouldn't talk about private access tokens. They would just talk about like Privacy Pass, or like the private token auth scheme type, of essentially saying what resources are allowed to include the private token auth scheme challenge. And that's all it would amount to. It's just kind of giving boundaries on who you accept these from.
And is there a dependency or an implementation of the newly adopted rate limited tokens draft, or is that not necessary for?
It's a bit separate. So the type 2 is supported, in production for us, with different issuers. We support kind of like beta testing with the rate limited types, but I don't think the type actually directly impacts what would be here in the permissions policy, for example, in W3C. That would just say, like, are you allowed to issue token requests in general? And then the actual challenge would include within it the type. And so if there's type 4 or type 5, whatever else comes out, I view this more as just a way to enable some communication about privacy pass in general at the like permissions policy layer.
Okay, thanks.
All right, unless there's somebody else who wants to join the queue. Thank you, Stephen. That was very useful. All right, next, I think we want to have kind of a chat on where Privacy Pass is and where we can, what sort of next steps might be. Were you able to share the deck? Yeah, there we go. So I think Ben will take us through some of this.
Hi, everybody. So we've got plenty of time left in the session, and that sometimes means that we're running out of things to do. I don't know that that's true in this case, but I want to ask the working group where they think this group should be going. So first, just to recap where we are right now, we have the architecture document that has completed last call. We're holding that just so that the architecture and issuance and auth documents can be considered together in the post-working group reviews. So we have the issuance and auth scheme documents in working group last call. Please do review and comment. Yeah, if you're very familiar with them, then you can just tell us that you think they're in good shape, but please comment on the mailing list. We have the recently adopted key consistency informational draft. It seems like we don't have any major changes in flight there. We have the rate limits document, which has a lot of attention on it, and Tommy walked us through some of the interesting things that are happening there, but it's making good progress. And I think the question is, what else do we want to work on? Is this, are we essentially wrapping up here, or are there other things that we want to do here? We had a draft in the past on consolidation considerations. We've had a lot of discussion about different token types, and the chairs recently got a request for a new batched token issuance flow. So that's something that people might want to work on. There's I have a draft on a specific consistency protocol. And there's an endless number of possible topics, but I want to know what the working group thinks is interesting. And also, just to remind people, we have a charter, and so if you want to talk about the progress we've made, we can compare it against the charter. Martin?
Yeah, I think on the consistency side of things, it seems to me like there's a very strong need to have something in this space concretely in addition to having sort of just a general guide of what consistency is and what it's good for and why it's important, I think there's a concrete need in some of these deployments to have a strong consistency protocol or system in place in order to provide the sort of privacy guarantees that we're hoping to achieve. Some of the proposals that I've seen really just don't work without something like that. There has been some more discussion this week about the exact shape of consistency protocols. I think Richard Barnes had some interesting ideas about applying something that's basically, how did he phrase that? Something like CT, but without all of the warts. So having that work happen here would be, I think, a good thing. This is, for better or worse, the group that has taken on that sort of work. I think it's integral to what we're doing here. But at the same time, I also think that discussion is fairly nascent, and I don't know that we're really in a position to make some strong decisions yet about the exact nature of those protocols, despite the fact that people might want to deploy things that depend on them.
Thanks. I see Stephen in the queue. I'd like, in addition to whatever you're planning on saying, I'd appreciate if you could share with us your sense of consistency in the W3C context. You mentioned that there's already, in a sense, a sort of proposed or draft consistency solution there.
Yeah, so I think the way we're doing consistency, like in the W3C, is very like flying by the seat of our pants, and it would be nice if we have something more standardized that like isn't just each UA is going to do their own like form of doing key consistency. I think Chris's draft is a good start, but I think we want something more structured coming out of that, either as part of that draft or as additional drafts. And then to my point, I was just going to mention that like as an additional token type, I think it's potentially like there might be some potential interesting stuff coming out of the ZKP solution to issue 6 from Tommy's proposal. And it might be worth having folks talk a little bit more about that and see if that's something of interest to pick up and whether that introduces new interesting work.
Thanks. You know, another thing I heard mentioned in this meeting or alluded to is formal verification. To my knowledge, there's no formal verification of the rather complicated cryptographic arrangements that we have been specifying. I wonder if anybody would be interested in working on that. Tommy?
I'm not the best person to talk about it. Chris Wood was driving more of it. I know Nikita's here, but I think for the basic types as well as rate limited types, they've had formal verification.
Oh, that's great.
Which is how the issue 6 came up.
Okay.
Nikita?
Yeah, I just wanted to, maybe I could say a bit more, is that there is a formal verification of the current protocol in using ProVerif, and other than this unlinkability issue, it shows that Tommy discussed. It shows the security properties, and I think there will be a write-up of it in the next month or two that could be made public.
Thanks. Philip?
On the topic of like future work and potential concerns, right now, when an attestation mechanism is compromised, any abuse that arises from that compromise will be felt by the relying parties, but the attester has no way of narrowing in on which devices are compromised and should be ignored or debugged. And obviously that's in tension with the blinding property. It's also unclear how the issuers can choose attesters and how relying parties assess the relative strength of these attesters and issuers. And some of that might come to bear in application over time. I'm also new to this group, but I'm very curious to see how that'll unfold over the passage of time.
Thanks. You know, one thing that this reminds me of is, thanks, Stephen, for the overview of the W3C side. I think it would be potentially helpful if we had a draft here that laid out, in a sense, one level above architecture, not just how the privacy pass system works, but how it's actually used, or how some different ways that we expect it to be used, that allow us to think through some of the details, like, can one origin drain your entire collection of privacy pass tokens, or are we expecting that there's some upper layer defense against that, and also walking through some of the difficulties that in those models. I would love to see an informational on something like that if anybody's interested. Richard?
Yeah, so since Martin mentioned my name, woke me up, I thought I might recap some of the discussion that we had in OI for folks who weren't there. So OI obviously has a similar key consistency challenge to Privacy Pass, and so there was some discussion about whether to do key consistency work there as well, and presented his double check proposal. In that discussion, it came up that there's actually a slightly more general consistency property that one might like for HTTP resources. Things like some applications might be interested in binary transparency, like guarantees that you're getting the same, web resources that other folks are getting. So it's possible this consistency property might be a little bit more general. The conclusion of that discussion at OHI was that, if consistency work is going to be done, Privacy Pass is, an instance where there's clearly a need for this. It's probably the most acute need for these consistency guarantees, and so this would be a good place to work on it. But it may be that there are solutions out there that are a little more general. So I don't know if we dive directly into the work here, or maybe we run some stuff through SIG dispatch. But yeah, I think it's doing a little bit more consistency stuff here is a sensible idea.
Okay. I hope that you've been inspired to contribute more interesting work to the working group. If you're working on formal analysis, it would be great to maybe see the results of that at the next session. And I'll turn it over to Joe for closing.
Yeah, I think that comes to the end of our regularly scheduled agenda. If there's anybody who has any additional topics, we can bring those up now. And if not, we can adjourn till next meeting. So thank you all for coming, and I hope you have safe travels back to wherever you are going. All right. All righty. Take it easy, Sam. How's it going, Paul?